Hello all. So in this video, I am going to explain the Leetcode daily challenge of 9/7/2022. The question is jump camp 6. Okay, in this question, they given us zero index array nums and integer k. If you are initially standing at the index 0, in one move, you can jump at most k steps forward without going outside the boundaries of the array. That is, you can jump from index I to any index in the range from I plus 1 to minimum of n minus 1 or I plus k, okay, inclusively. So you want to reach the last index of the array and your score is sum of all num j you visited, okay. So you want to get the maximum score by jumping to reach the last index. For example, you are initially starting at this position. Now you're going to jump into the first cell, and from first cell you can jump to the next two cells. Okay, you are designed to jump to the third index, sorry, fourth index, so third index. So from third index you're going to jump into fifth index. Okay, so in this path you scored maximum of 7 points. Okay, your sum score is 7. Okay, this is the maximum of this array. Okay, this is the maximum way to reach the last point. The same way also, in this example, you are standing at this position, so the score is 10, and next you are going to jump into the fourth index because you can up to jump 3 cells. Okay, you jump next to this cell with value 4. So now the score is 10 plus 4, 14, and next you are going to jump into this. Okay, this is 3, so total sum is 17. So this is the one of the maximum answer. So this is the question. We want to find the maximum value by jumping into cells to reach the last cell. Okay. Okay. In this problem, we can solve using dynamic programming easily. Okay. You can solve. You may solve many type of questions. This type of questions. So, but there is a twist in that. Okay. I will explain in the algorithm section. Okay. Now move on to the algorithm part. Okay. Now I take the example which is given the question. Okay. Now the input array is this is okay. The first minus 1, 1 minus 1 minus 2 4 minus 7 3. Okay. Now I am currently standing at this index. Okay. I am currently standing at this index. Now to reach this index is I can only go. So I am directly present is that. So I can maximum score I can get is 1 because I am currently standing on this point. Next, to reach the second in first index, I can came from 0th index. Okay, so this is one of the possibilities. So maximum score I can get is 1. Okay, 1 plus minus 1. So this is the one of only one way to reach this first index. Okay, so maximum score is 0. Okay, now I am currently present in the second index. Okay, to come into second index, may I can come from 0th index or first index. So this is the only two possible ways. Okay, whether may I come from 0 to 2 or 1 to 2. So now I want to choose the answer greedily because I want the maximum score. So the maximum value is in this 2 point is this. Okay, so 1 is the maximum value. So 1 plus my current cell value is minus 2. So 1 plus minus 2 will give us minus 1. Okay, minus 1 is the maximum value I can get to reach the second cell. Now I move on to third index. Okay, in third cell, to reach this cell, may I can come from this first cell or this second cell. Okay, only two possible ways because my window size is 2 only. I can jump maximum two cells. So to reach this cell, may I can come from this first cell or second cell. So now I want to choose again greedily. So which is the maximum value 0. Okay, 0 plus 4 is 4. So maximum value to reach the third cell is 4. Again I move on to the fourth cell. To reach the fourth cell, may I can come from first cell or third cell. So which is the maximum one in this 2 points? So 4 is the maximum one. Okay, so my maximum one is 4. So 4 plus minus 7 is minus 3. again I move on. To reach the fifth cell, may I can come from third cell or fourth cell. Okay, which is a maximum value? The third cell, which is value is 4. So now update the fifth cell value. So 4 plus 3 is 7. So the maximum score I can get to reach the fifth cell is 7. Okay. So now we have a question. So the problem can be easily solved using this way, but we want to find the maximum of the window size. Okay. Okay. For example, to reach this cell, I want to find the maximum of this window values. And also to reach this cell, I also want the maximum of this window size. To reach this cell, I want the maximum of this window. Okay. How I going to find this value maximum in very less time? So this can be solved using Monoqueue. So maybe you are aware of the Monoqueue. If you're not, I don't worry, I will explain that. Okay, now how we can solve this problem in using Monoqueue? I will explain. Okay, let's erase all. Okay, now I'm going to solve this using DQ. So to this, first again I'm going to start from the 0th index. So I'm currently at the present at the 0th index. So this value is 1. Okay, now I'm going to update this DQ because now DQ is empty. I'm going to update this 0th index. Okay, now I move on to next index. So to reach this first index, I may come from 0th index. Okay, instead of checking directly in DP, I'm going to check this in DQ. Okay, I can come from this index because DQ always store this Monoqueue always store the maximum value I can to reach the first to this index. Okay, so DQ work is to store the maximum value to reach the index. Okay, so I will if you move further you can understand. Okay, now I reach the first index with value 1. Okay, 1 plus minus 1 is 0. Again I going to push that into, now before pushing into Q I going to check condition. Okay, whether the last element I inserted into the DQ is, okay, last element present in the DQ is smaller than the current element or not. Okay, the current element is 0. You can see the last element which is in the DQ is the 0th index value is 1. I want to check whether it is greater or not. So it is greater. So I going to do nothing. I just inserted this index into DQ in back. Okay, you can see the front of the DQ is the maximum value okay, this is the maximum value you can see. Okay, this is the main concept of the Monoqueue. Now I move to next index. Okay, now I am currently in second index. So to reach the second index, I can come from 0 or 1. So to choose maximally, I am going to check in DQ. So which is present in the DQ first? So 0 is present in the DQ first. So this is the, so I can know this is the only way to reach the second index with maximum value. So I can come from 0th index. So which value is 1. So 1 plus minus 2 is minus 1. Okay, now I'm going to check again. Going to check with DQ. I want to update the DQ. So if you see the DQ's current value is minus 1, but DQ front is first index, so which is value is 0. So which is greater than? So 0 is greater, so it is smaller. Okay. So I going to do nothing. I going to, so it is the condition space, so I don't want to, so I just added this index in the last of the queue. Okay. Now 2 is added at the end of the queue. Okay, again I move on to third index. So before moving to third index, I can see the window size is reached. Okay, because this is the 2 size window. Okay, now the window size is moved. Okay, we moved more than, so I want to remove the 0th index from the window. So you can see, so before removing this 0th index, I want to check whether it is the current max or not. Okay, I'm going to check the DQ.friend. It is the so it is the current max. So I want to remove that. Okay, so if I so I'm going to remove the DQ value. Okay, so I'm going to remove that. Okay, because the window is moved. Okay, to reach this level, I can only come from 1 or 2. So if I choose the 0th index, so it is not the optimal one. So this is not a correct one. So now I'm going to, so now I want to reach the third index. So I want to check again DQ.friend. So which is first index. So which is value is 0. So it is the only one which is have maximum value So 0 plus 4 is 4. Okay, I'm going to update this. So before updating, I want to check that whether it can be. So in third index the value is 4. Again I'm going to check in dq dot back. So in back there is a second index value which is -1. So which is smaller than the current value. So in greedily I'm going to delete this. Okay, I'm going to delete this value. Again I'm going to check with dq dot back. So okay, in back there is again 1. So in one first index there is value 0. So which is also smaller than this. So it is also not optimal to further cells. Okay, again, so for this concern I again delete this. Now this queue become empty. Now I'm going to insert this third index into the queue. Okay, now I'm going to fourth index. To reach the fourth index, now again before moving to fourth, to reach the fourth index I can come from 2 or 3. Okay, this is the two possible ways. Okay, so now I'm going to check again dq. The dq is so before checking the dq, I'm going to check whether the dq dot friend is less than this second index, because we cannot reach the second before from 1 cell to 4, which is not possible. So I'm going to check this whether the dq dot friend is less than the window size. Okay, it is not, because this is just third index. So now I'm going to update this fourth value. So the if only we can come to this cell is third index. So 4 plus -7 would be -3. Okay. Again, I'm going to update this dq. Okay, now I'm going to update the fourth index. Again, I'm going to check in the dq. So dq value is 4. So dq is 3. So which is 4, which is greater than this. So I'm going to do nothing. I just add the push the current index into the last of the queue. Okay, 4. Again move to fifth index. So to reach the fifth index, I'm going to push the from the front. So 3 plus 5. So in third index the value is 4. So 4 plus 3 is 7. Okay. So again I'm going to check to remove the so 7 is the current maximum. So I'm going to check the fourth index. The fourth index is less than this. So again I'm going to remove this from the dq. Again I need to check this third index. Then third index the value is 4. So it is also less than that. So again I'm going to remove that. So now queue become empty. So I'm going to push this fifth index to the dq. So now the maximum, so we reach the final cell. So it's the solution to our problem. So this is the maximum value I can get by jumping into the last cell. Okay, so this is the concept. Hope you can understand that. If you did not understand, please try to write in note and pen. Okay, you can clearly understand the concept. Okay, now move on to the problem. Now move on to the code. Okay, so initially I found declared the dq double-ended queue. So now what I explained in the algorithm, it's the same way I'm going to do. So I iterate from the first 0th index to last index. Okay, if the dq is empty, just I will, instead of dp, I'm going to directly store the value in the given array, because it will reduce the space. So you can also use the extra space to dp, but it's not necessary, because we don't going to reuse the nums value again. So I directly store the dp value into the nums. Okay, if the dq is empty, I just literally 0, because in first index you can see in first index or sometimes the dq becomes 0. So that time there is no previous cell. So it is 0. If it is not, I'm going to add the value which is present in the dq dot friend. Okay, I'm going to add the dq dot friend value. After that, I'm going to check. I want to update the Monoqueue. Okay, in Monoqueue, if the dq is now while the dq is not empty and the current value is greater than the Monoqueue last value, so I will remove that from the Monoqueue until the current value is greater than the Monoqueue's last value, because it is the only way to you can update the. So it is the basic structure of the Monoqueue. You can also read more about Monoqueue in internet. Okay, after that I'm going to push the current element to the last of the queue. Okay, if the first element is less than our window size, which is mean dq dot friend is less than or equal to I minus k, which means this is not going to that cell should not be present in the our answer. So we are going to remove that cell. Finally we return the nums dot back value. last value present in the nums. Okay, let's submit this problem, submit this solution. Okay, it's accepted. Okay, the time complexity is, we can see we iterate only one time again, but you can see there is another loop within that, but it's not. So it's just only it visit the elements only once. Again, this loop also visit the only elements only once. So it is just 2 into n. So the time complexity could be order of n, and the space complexity is also order of n because we use the double-ended queue. Okay, hope you enjoyed this session. If you have any doubt, please kindly ask in the comment section. So let me see in the next video. Thank you.